Right, guys, I hope these are the last examples we looked at when we were doing our solution of equations involving complex roots. Now, what I want to do today is to discuss one more example. My assumption is each one of you attempted these exercises. Is that all right? Okay. So you should have attempted these exercises. If you've got any questions, you can come back to me and check whatever is happening there. But the exercise the example which I want to discuss today is the following. Warning, this is a bit kind of a lengthy discussion. So please try to pay attention and make sure that you get all the necessary things. Now, look at the exercise, what the exercise says. Always was still continuing the solving quadratic equations in the set of complex numbers. So we're expecting this equation to have a complex roots. But the exercise says, factorize it completely and hence find the complete set of zeros of PZ. Convention, I'm talking about kind of a gentleman's agreement, or maybe gentleman and lady agreement to be politically correct. A convention is whenever in this case I use PZ, I'll be trying to insinuate that the equation has got what? Complex roots, because we use Z to denote complex numbers. Is that right? Okay. So now it says factorize completely and then give a complete set of zeros of PZ. Now, let's start. How do we start? Observation. Those are things you shouldn't overlook. You look at the degree of the polynomial. The highest power of Z in the polynomial is 5, isn't it? That must tell you something. From a theoretical point of view, we already can establish that this equation is expected to have 5 roots. Are we together? Okay. This is how I decided to solve the equation. For organization, I will say this is step number 0. In other words, when I'm saying using 0, I'm normally referring to the initial step. Let's say, what is this? I don't know what's happening. I'm trying to get a thinner line. I'm not winning. I don't know why. Okay. Right. Let's say the initial step 0. I'll do it that way. We're dealing with the PZ. Let me repeat PZ there and say I'll write it as P5Z. This is just my way of trying to indicate that I'm dealing with a polynomial of degree 5. Say Z power 5 plus 3 Z power 4 plus 2 Z power 3 plus 2 Z squared minus 4Z. Now, if we are to factorize, in this case, we have to evoke our factor theorem from school. If you remember the factor theorem says if you've got P of A equals to 0, then this kind of a term, Z minus A, is a factor of the polynomial. You know that one, isn't it? Okay. So immediately what you can see here is that for A equals to 0, you substitute 0, 0 here, all those Z, this P is going to be 0, isn't it? So according to this, Z minus 0 is a factor, which actually means that Z is a factor of P5, PZ5. Somebody must say, why do we have to use 5 here to indicate the power of the polynomial? You will see what happens as I go here. Is that right? Yeah. Okay, is a factor of that. So now, if I've got a factor already, which means I can write this now, this 5 is a product of z and another polynomial of p4. So then I say here, therefore, p4 is equal to p5 divided by z. I mean, if I know that 2 is a factor of 6, to get the other factor, I divide 2 by 6 by 2, isn't it? So that's what I'm doing there. So what I'm getting here, I'm going to get z power 4 plus 3, z power 3 plus 2, z power 2 minus 2, z minus 4. Am I correct? Just check that I'm writing things correctly, because sometimes I can say something and write a different thing just because of a slip of a pen. You must monitor that. Is that correct? Okay. Now, in our next step now, unless I will call this 1, now we are dealing with P4. P4 z power 4 plus 3 z power 3 plus z2 z power 2 minus 2z minus 4. Right. So my use of this 4, 5 there, I'm just trying to indicate to you that as I'm getting factors, the polynomials, the polynomial I'm going to deal with, they've got a reduced what? Like here now, I've got a polynomial of power 4. So if I continue, I'll get a polynomial of power 3 until I get to a polynomial of power 2, which I may factorize or use the formula to get the roots. Is that right? Okay, that's the idea of using that thing there. Now, effect. Possible zeros here. Let's write here, possible zeros are factors of minus 4. I'm using a theorem here, very important theorem, which I'm not going to really be interested in saying Pythagoras theorem or whose theorem. I'm just using a theorem. Maybe later I'm going to refer to that name, but this is a theorem that if you've got a polynomial like this, and it's a particular case of theorem, because this is not the exact theorem. I'll show you later when you've familiarized with this, what does the theorem say in general. Is that right? This is a particular case. Why particular case? I'm actually looking at a particular case where the independent term here is a number different from 1, when the leading term there is a number equal to 1. Actually, the particular thing about this polynomial is that the leading coefficient there is equals to 1. Otherwise, I wouldn't say this. What would I say? You will see it when I come to that case. Altogether. Okay. So, vectors of minus 4, minus 1 times 4, minus 4 times 1, minus 2 times 2. Anything else possible? Any other combination? I take all the possible ones because I don't know. The theorem says if we've got a polynomial like this, the zeros of this thing should be one of the factors of minus 4. But then I'm just taking all of them and I will do what I call try and error thing to see which one is the one, isn't it? So when I identify it, I'll pick it. But maybe I'm doing some kind of cheating here. I didn't say teaching, I said cheating. Because I know this thing because I did it before, isn't it? So what I'm going to do here, I'm going to say, okay, let's try P4 of 1. Why pick on 1? I think 1 is the simplest number, and the other thing, because I prepared this thing, I know exactly where I want to go. I don't want to go testing things so I don't want, which are not going to give me the right thing, is it? But you can test the other values and see what happens, isn't it? So what I'm going to do here, I'm going to say 1 power 4 plus 3, 1 power 3 plus 2, 1 power 2 minus 2 times 1 minus 4. I'm using that. I think 1 is a very simple number, which really I don't need really to write 1 power 3, but I'm just using that kind of structure to show you what you do with any other number. Is that right? Are we together? Otherwise, I should have just written 1 plus 3, 1 here plus 3 plus 2 minus 2 and minus 4. But what I'm trying to do there, I want to show you the real substitution you must do with any other number. Are we together? It's because here now, I'm teaching, I'm not cheating. Yeah. Now let's see what happens here. 1 plus 3 will give us a 4. Plus 2 will give us a 6. Then here we've got a minus 6. Then this is what? 0. So according to the theorem, therefore, Z minus 1 is a factor. A factor of P4 of Z. Am I making myself clear there? Are we at the same page? Everybody's there. Anyone, please don't remain behind. Please don't remain behind. That's criminal. Are we there, guys? Okay. So now, what's going to happen now? Then we can say now P3 of Z is going to be P4 of Z divided by Z minus 1. So as you can see now, we cannot do the same way we did with Z. All together? Okay. So now we don't have a choice but to do what is called long division. It will if you have never done this thing, you are seeing for the first time, good luck, please try to learn it. Otherwise, I'm tempted to say not doing it before this is actually a criminal act. So what are we dividing here? We're dividing Z power 4 plus 3 Z power 3 plus 2 Z power 2 minus 2 Z minus 4. These are some of the things which you cannot easily get from a calculator. Maybe you can get another software, you can do it for you, but the day there's no electricity, which means everything will stop wherever you're working with these things. But we're not going to do that. Let's understand how we do this thing. So what do? We normally take this leading term here, which is normally a linear factor like that, a linear term like that. We divide this leading term there. If we do that division, it's the same like the same division we did in the first step there with Z. All together. Then we're going to get Z power 3. Do you agree? Okay. This is called long division. Do you agree? Okay. You could also do it in numbers, isn't it? You know how to do it in numbers, normal numbers. Because if you don't know how to do it in numbers, 1000 something, blah, 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 blah. It actually doesn't make sense what we are doing here. But if you know how to do long division with numbers, it quite makes good sense what we are doing here. But if you don't know how to do it with numbers, you can come to me, I'll teach you. Then we multiply that by z. This by z. You get z4. By z4 means z to the power 4. Then you get minus z cubed. If you have got 10 to the power 3, you've got thousands. So you can see there I'm putting thousands under thousands. Maybe tens of thousands under tens of thousands. Then I say subtract. I'm subtracting this from the top. Are we there, guys? Okay. So please make sure that you can see what I'm subtracting and the way did I get to what I'm subtracting. You know what I'm subtracting? Okay. Then if I subtract here, I get a 0. Normally we put a dot like that. I get a 0 there. If I subtract here, it's a positive number minus minus, which is that is addition. Then we get 4z cubed. Then I bring this one down here plus 2z squared. Are we there, guys? Then we divide now by this leading term again here. If we divide here, I think we're going to get plus, who can tell me? Somebody tells me. Tell me. Come again? 4z squared. Right? If I do the same multiplication, I'll get here 4z cubed minus, is that minus? Minus what? Minus 4z squared. I put this in brackets again, minus a 0 again there. When I come here, what's happening here? 6. Is that a 6? I'm not very comfortable with that 6, no? Is a 6? Okay, it's a 6. Then what do you do there? Bring down 2z, is it? Okay. Then we divide again by deleting same. You see my arrow there? It looks like we're going to go back there, I don't know, until something happens. So then, if we divide there, we're going to have a 6z. Are we there? Then we multiply there, we're going to get 6z squared minus what? Minus 6z, minus or plus? Then we get a 0 again there. We get a plus 6 minus 2. We get a 4z, isn't it? Then we get a minus 4 down there. So far, anyone who is lost? No. Good. Now we divide again there, we get a plus 4. Then you multiply, we get a 4z, we get a minus 4. We subtract, we get a 0. Obviously, something 2 is a factor of 6. You divide 6 by 2, you can't get the remainder, isn't it? So that's the thing. So we continue now. So what do we have there? We have that this P4, this P3 is equal to that. Maybe you can write it nicely down there at the bottom and say P3 of Z equals to z cubed plus 4 z squared plus 6 z plus 4. I think now we're in a position to get to step number 2. Initial step 1 and 2 all together. So, but don't lose sight of the factors we've got all together. At this stage, if we multiply this one by this factor by the first factor, we still get P5 all together. So we mustn't lose sight of that. So now let's go and say now, let's come in and say now, step number 2, we're having Pz, P3z equals to z cubed plus 4z plus 6z plus 4. Guys, there's one thing which you must learn, or maybe you must educate yourself in. You know, what we're doing now, like step by step like this thing must actually instill in you some kind of patience, some kind of tenacity in following things step by step altogether. Those are things we need in life. People do things, they actually plan and they do things step by step, like saying Rome was not built in one day. Why did we start? We started with the easiest factor, which was 0. We go to the next one. Step by keeping track of that detail is a very important skill in life. If you didn't know, please learn it today. That's bonus. I told you, I'll teach you everything. Is that all right? So, apart from applying this thing in engineering, this thing is also trying to modify your character. You must be patient, be tenacious, and push up to the end. All together. So now we can say now here, again, possible zeros are factors of plus 4. Why am I writing that possible zeros of that thing? Is that mathematics? Huh? Why am I writing this? Is this mathematics? It's part of it. You can't just write calculations without communicating them. You communicate your calculations. You must communicate your calculations. Because there's sometimes somebody just write calculations equal signs equal. You don't. Somehow you get lost. What is this guy trying to do? But some kind of wordings like that to guide the person who's marking and they show the direction we are going is very important. It's very important. It's part of the solution. All together, guys. Okay. So what do we have there? Now we get. I said it's factors of plus 4. I know that plus 4 I can get it from minus 1 times minus 4. From 1 times 4 minus 2 times what? Comes minus 2. 2 times 2. Those are the possible factors. So ideally you will take each one of them. I think the most logical thing is to start with the simplest numbers like 1, minus 1. You go to the factors bit by bit, you'll get one of them. It's not all of them. It's possible are these, but then I'm just suggesting that I can start from my 1 and then 2, whatever, and go on that. Like for example, it's clear that if I start with 1 here, just roughly start with 1 here. You got 1, 1, 1, which is 1 plus 4 plus 6 plus 4. It cannot be 0. It's very clear, isn't it? If I get minus 1, it's almost clear also. Here is going to be 4, and then with this one will be 8, and this one will be 1, and this one will be minus 7, and 8. The difference is not going to be 0. Then I'm going to do, I'm going to go to minus 2. Let's say P3 minus 2 It's also very important to be able to manipulate numbers like I'm trying to do now. I'm not trying to say I'm clever. No. Listen, I've been sitting on these things for I don't know for many years. So the mathematics is a problem of doing it. It's not just a question of saying you know it, then whenever you want to do it, No, it cannot happen. You have to sit on this thing, practice, and as you practice, you get into the system and you'll find it very easy to manipulate these things. Are we together? Okay. Practice makes perfect. I'll not say the other one because I'm going to record this one. Okay. So what happens? We can say here that minus 2 to cube squared minus 2 power 1 plus what? Plus 4. Check rough what are we getting here? Let's expand this. We're getting minus 8. What are we getting here? 12, or 16, sorry. We're getting minus 12 here. All together. What are we getting here? Plus 4, isn't it? If you look at this, 16 and 4, they give you 20. 8 and that, they give you minus 20. Then this is equals to 0. What does it say? Therefore, Z minus 2 is a factor. The theorem says Z minus A. So I'm respecting the theorem there. The A is minus 2. I'm saying Z minus A. What will follow later is something else. It's called combination of signs. There's nothing to do with the theorem. So Z plus 2 in simplest form. Then we can now say P2 of Z is equals to P3 Z divided by Z plus 2. One message which is being sent out here implicitly is that whenever you are factorizing, there's no way you can run away from division. Altogether, when you've got AB plus AC, to factorize, to take out the common factor A, you actually have to divide each term there by A, isn't it? Then you write A outside the bracket. So division and the factorization, I don't know what you want to call those two, but you cannot do one. We cannot do factorization without division, according to my observation after so many years of playing around with these things. We are dividing here by Z plus 2. Same story which we did before, repeated. So it's like I'm doing two examples of division. So you are getting getting 2 at the price of 1. So Z, dividing that leading term there, you get Z squared. Then you get Z cubed plus 2Z squared. You subtract you get 0 here, then here you get 2Z squared, then you bring your linear term 6Z down. I actually wish that everybody was writing this thing as I'm writing it. Feel it. And I can see that there are some guys who are just seated and watching, as if they're watching Generations on TV. That is dangerous. I'm telling you, you'll understand this thing better later when you listen to the video clip, when you were participating actively, writing and checking things I'm doing, substituting the -1s, the -2s, pushing the pen against the paper as I was doing. You will understand it better when you watch the video clip. Advice taken or not taken? But you know, it's free of advice. I'm not going to ask you to pay any consultation fee. So Z dividing this one here, you're going to get plus 2Z. Multiplying, we're going to get 2Z squared plus 4Z. Subtracting this, I get here 2Z. Then I bring my independent term down there. Now, I think this is our last division now. Divide there, the leading term again, you get a 2. Then what are we going to have there? We're going to have 2Z plus what? 4. We subtract, 0 is the remainder. So which means now our P2, you see my use of 5, 4, 3, 2 is exactly, I'm numbering here, trying to see that I'm not missing a step in between. And this is what we have. And when we get here, you can try factors of 2. But unfortunately, factors of 2 are 1 and 2, -1 and -2. If you try them here, try 1, you can see clearly. It did not happen. 2, positive 2, you can see clearly it is not going to happen there. So this is no real roots. Which means then now we have to appeal to complex roots, and to get to there, we need our quadratic formula is the easiest thing to do here. So what we need to do, we can now say there are 2 zeros here, Z1 and Z2, they are called to be a fraction of this nature, minus B, which is -2, plus minus square root of B squared, which is 4, minus 4AC. C is 2, A is 1, 4 is 4, that is -8. Over 2A, 2 times 1. Am I losing anyone there? Sorry? I'm reading the formula into what I'm doing because I know the formula from my memory, not because my memory is good, no, because I've repeated it several times. Then I have to get the -2 plus minus, here you're going to get the square root of -4. And the -1 is J squared. So if we simplify that, we're going to get 2J all over 2. And then this gives us -1 plus or minus J. So as you can see, there are 2 roots there. A number, a complex number, and its conjugate altogether. So which says this P2 is actually Z minus, in one case, -1 plus J. Brackets, that is a factor. The other factor, Z minus, brackets, -1 minus that Why I'm writing that this way is because I'm a slow learner. Are we together? And I'm expecting several other slow learners in my audience. So I'm writing it as slowly as possible. This is my A, isn't it? The bracket is my A. The bracket is my A. So now writing this in simplest form, this will give me Z plus 1 minus J. Brackets Z plus 1 plus J. Therefore, my P, which is my P5, I'll just now drop 5 and go back to my P, will be Z. What was the next factor? Z minus 1. And followed by Z minus plus 2. Then followed lastly by this 2, which is Z minus 1, plus 1 minus J, Z plus 1 plus J. That is my polynomial factorized. Then he says find the complete set of roots. This sounds like a repetition of the same question what we have tried, but to get the roots now, we just need to say P Z equals to 0. It means that this product is equal to 0, isn't it? So then, which means that we can say now Z minus 1, Z plus 2, Z plus 1 minus J, Z plus 1 plus J, all that equals to 0, which means that Z equals to 0, or Z minus 1 equals to 0, or Z plus 2 equals to 0. Z plus 1 minus J equals to 0. Z plus 1 plus J equals to 0. I think simplifying these last 4, we get here that Z equals to 1, or Z equals to minus 2, or Z equals to minus 1 plus J, Z equals to minus 1 minus J. And guys, please, never dream of giving a solution for an equation which involves complex roots and then see yourself with an odd number of complex numbers. They always come in pairs. Are we together? They always come in pairs. So if you want to give this as a set, I would say now zeros of PZ. As a set, I would say zeros of PZ. It's 1. I'm listing them now. Minus 2. I'm giving that as a set. Or 0, sorry. I forgot 0 here. 0. Then minus 1 plus J. Then minus 1 minus J. Then that's the complete set of zeros. Right, guys, comments. What do you say? This is the complete set of zeros. I've given there my complete factorization of the expression, and this is the complete set of zeros. Obviously, don't ask me how many marks you're going to give for this. I will decide myself. Come again? No, this is optional. As long as you make it clear that these are the zeros, it's not important how you write it. You can give it as a set. You can say you can give them the first word. It's fine. But the most important thing, communicate your work clearly. Don't just throw numbers around, and I cannot even read what is which and what is which. All together. So guys, there is this thing. I mean, you can see, really, I don't know what you say, but people can say all sorts of funny things. But myself, this thing is actually character modifying. If you don't have patience, natural, you cannot do this thing. So if you don't have patience naturally, what you need to do, you need to do this thing. For mathematics to train you to be patient and to follow detail and to move from step to step, comma to comma, full stop to full stop, and you don't miss the detail. Because once you miss one thing here and you do something slightly wrong there, you are gone. And at the end, you end up with maybe a good chunk of nonsense. And then when I mark it wrong, you get offended. But there's nothing I can do. All together, guys. Please, there is the discussion. I hope you go through it again and really try to get it's very difficult to do 2 examples like this in one class. Sometimes it's not possible. But I think what we've done now can give us some chance to attempt a number of exercises. All right. Thank you for listening attentively. I see people listening very, very carefully. Yes, do you have a question? Yeah, there I'm using that set. I'm just using a derivation, or I didn't explain. I remember I didn't explain it. So I said the zeros of PZ as a set is equal to that. Isn't it? Yeah, that's that's just a notation. Or you can just say set solution. Then you just put your set there. All together. Did you hear what he said? He asked the question. He's asking whether that Z which I put the Z brackets PZ. What does it mean? I'm saying zeros of the polynomial PZ equals, I'm using that as a name of the set, then I'm giving it like that. All together. But the alternatives, you can see examples in your book or something else. You see, you can use something else. Okay. Thank you for the question and thank you for listening attentively.